Good morning, class. Welcome to the online classes for physics of class 10th. Already we have completed our first term portion online, that is your light reflection and refraction, and the second point, that is the human eye and the colorful bulb. What we have seen that in the light reflection and refraction, we have seen what the light is, what were the properties. Secondly, we have seen that what types of mirror we are using for the light, that is the optical part, that is one is concave mirror and the second one will be convex mirror, which was a part of a spherical mirror, that is a part of a hollow spherical glass shape which will be curted, which will be converged inside or the bulged out outwards, so then they will have a type of mirrors. Similarly, we have seen that the light falling on that particular object, we have different types of the phenomena, and that phenomena also we have seen that one was a kind of reflection and another one was a kind of a refraction. So if we talk about the refraction, then it is the bending of the light ray when it passes from one medium to the other medium, and if we are talking about reflection, then the light ray, so bouncing back from any surface is said to be the reflection. So we have seen the angle of incidence that was equal to the angle of reflection every time. For that we have took an imaginary perpendicular line that was taken as normal, and that angle of incidence should always be equal to that of angle of reflection, and these three lines, that is incident ray, normal ray and the reflected ray, should always be in the same plane. And similarly we have seen the lens, that is it will be taken as the two spherical mirrors together, that will have a wider part in the edges. You can say that it is wider, then it will be taken as concave mirror. If you take about the thinner edges but wider at the middle part, then it will be concave mirror. So this is the different types of lens we have taken, that is different mirrors will be taken together, then it is taken as lens. And after taking the lens, we have seen that in lens refraction also used to be done. And in the human eye colorful world, first topic which we have read was the type of the parts which we are having inside our human eye, its construction and the function of the different parts. After that we have seen the atmospheric refraction, internal reflection, what was deviation, and the dispersion of the white light, that it splits up into its 7 constituent colors, and after passing through it, it get internal reflection also, then only we can see that 7 splitting colors, that is the spectrum. After that we have seen that in a prism the angle of deviation was also there. We have seen the relationship between the angle of deviation, dispersion and bending of light ray, its wavelength, that is the red light used to have the highest wavelength but the lowest angle of deviation. Similarly, violet ray has the lowest wavelength but the highest angle of deviation. Similarly, we have seen scattering also, that is the scattering, the path of the light that scatters from a true solution cannot be seen, but similarly for the colloidal particle that will pass through that, we can see it, that is the intermediate particles used to be larger than that of the true solution in the colloidal zone. In that we have seen the Tyndall effect also, that is whenever the light falls on the surface, then it gets split up and that the path can be seen. That is in the forest when the sunlight comes between the trees, there also we can see. And the blue light of the sky, because the blue is having the lowest wavelength, then it just get scattered very easily and it disperses throughout the sky, so blue light will be more visible to us. Okay, so today we are going to see the revision for this, some MCQs also. Here you can see the first MCQ, that is we will try to solve it all, that is the focal length of the plane mirror is. If we talk about a plane mirror, whether we can find out the focal length, that is the distance between the optical center and the focus. So can we find out the focal length? No, because in the plane mirror we cannot find out the point where the image formation is there or where the actual meeting of the rays are there. So the focal length can also be not measured. So we can say that it is not 0 also, not negative also. So it will be infinity. So the focal length of the plane mirror will be infinity. So then the second one, that is the image formed by the plane mirror. So image formed by the plane mirror is always a virtual and the erect image, right? What's the third one? That is a concave mirror gives real inverted and the same size image if the object is placed at same size image, and we used to get a inverted also where the object is placed at the same size image also from where it is, that is if we take it at f, then it will be formed at infinity. If we talk about infinity, then it will be at focus. So if we talk about C, then we get an inverted image at the same size, so that it will be center of curvature. After that, power of the lens is minus 40, then its focal length is, So what it is, that is we can take the inverse of the power of the length, that is 1 by f also we used to take. So there also we can find out the value, that it will be 0.25, and since it is given here minus, so it will be minus sign of the 0.25. Now the next question, you can see that a concave mirror gives virtual enlarged image of the object, but image of the smaller size than the size of the object. Then where the object should be kept? Think of it once. That is, the object should be, because at infinity the object will be at focus and the size will be of different size. That is, if we taken about the focus and the center of curvature, and if pole and focus, then the image of the smaller size is formed than that of the object. So the answer will be pole and the focus. Similarly, see the next question, that is, in optics, an object which has higher refractive index is called. We know that when the object is dense, then we used to get a refractive index to be maximum value, and for the low density is less than, that is for the rarer medium, they will get a less refractive index. So the value, that is the answer for the highest refractive index, it should be denser. Here the refractive index cannot be. If you talk about optical density, it just tells about the value. Rarer medium cannot have the highest refractive index, so the only answer is optical denser. Optically denser objects will have the highest refractive index. If we talk about the optical phenomena, that is the twinkling of stars. We have seen this topic in the last session itself, that what is the twinkling of stars? That is, whenever the light ray that is coming from the stars, we have talked about the apparent position and the actual position, that whenever the light ray that is coming from the star, it passes through different layers of the atmosphere and moves to us. That is, when it moves from the denser to the rarer mediums, and again hotter to the air, that is cooler airs, and what it happens, it gets reflected a lots of times, and it enters our eye, due to which we can, there is a wavering and the fluctuations on the light rays, and due to this wavering and the fluctuations, the position which we are seeing is not the actual position of the star, it is the apparent position. So this is due to the atmospheric refraction, not reflection. It will be refraction because it is passing through the different mediums, and there will be some deviation in the light ray, that is, they get bent. So this bending of the light ray is said to be the refraction, and this is done in the atmosphere, so it will be atmospheric refraction. If we talk about total reflection, it cannot be done in this, so the only option is atmospheric refraction. Now the next question, that is, convex lens focus a real point sized image at focus. The object is placed at, we know that whenever object is placed at infinity, we get the image at focus. If we kept the object at focus, then we get the image at infinity. Here what it is saying, that the object is placed at, where the object should be placed, with the image at focus, and the object should be at infinity, so it will be at infinity. Okay, now see the ninth one, that is the unit of the power lens. So what will be the unit of the power lens? We know that the power of the lens is given by diopter, this is taken as diopter, so it will be the option diopter. And at the last, what it is given, the radius of the curvature of the mirror is 20 centimeter. The focal length is, what it will be, just half of it, so focal length will be the half of the radius, that is given as 20 upon 2, which will be 10 centimeters. So this is what the answer is. After that, see this question, that angle of incidence for a ray of light having zero reflection angle is. So if the angle of reflection is 0, so what will be the angle of incidence? We know that angle I will always be equal to that of angle R. So here given that angle R is 0 degree, it is asking if R is 0, then what will be the value for I? Then I should also be 0 degree. Here it will be the option A. So it will be option A. Okay. So see the next question, that is, which of the following mirror is used by a dentist to see the or examine a small cavity? We know that to see the smallest object, if we get a larger image, then we should use a concave mirror. So dentist used to be done with a concave mirror. Okay. Now the next question, light travels from a rarer to a denser medium, it will have dash. We know that whenever the light ray, it moves from the rarer to the denser medium, we know because the velocity will decrease, because the obstructions will be larger for that denser medium, so the velocity will decrease. This is the point where the velocity is decreasing. But we know that the light ray, when it passes, its wavelength will also decrease, because we know that the wavelength value, that is, if it is taken as v, then v will be nu lambda. Here nu is the frequency, lambda is the wavelength. So always the velocity is directly proportional to that of the wavelength. So if velocity is decreasing, then wavelength should also decrease. So what we can say, that the light rays wavelength and velocity both will decrease if they are passing from direct to the denser medium. Next, that if an incident ray passes through the focus, the reflected ray will parallel to the principal axis, because whenever the light ray passes parallel to the principal axis, it will pass through the focus. If the incident ray passes through the focus, then the reflected ray will be parallel to that of the principal axis. Okay. Focal length of the concave mirror is, we know that for concave mirror, it is on the left side, that is focus is on the left side, and the distance from the focus to the optical center is taken as focal length. So the value of the focal length will be in the left side, and we know that the quadrant, according to the axis of the quadrant geometry, it is in the negative side, so the value will be negative. So the concave mirror, we can say that the focal length will be negative. Okay. So these are the type of the MCQs that we can see about the lights chapter. We will be seeing more MCQs also, because this week, in this 2 weeks, you will be getting your revision work only for the online videos. So you can just see the videos and you can ask if you have any queries also. So thank you class, and start doing your preparation for the term 1, and all the best.